All right, for the data shown, answer the questions round to 2 decimal places. So we've got this list of data here, which I've already entered, stat edit. So there's my list of data right there. So it says find the mean, find the median, and find the standard deviation. So at this point, I'm pretty sure you know how to find the mean of this by hand, right? We're just going to add them up and then divide by the number of things. I'm just going to let the calculator do that for me. So we're just going to go stat calc 1var stats on list 1. And there's the mean. So I know x bar is equal to 15.44. And remember that the calculator also shows us the median, which is 16.7. Okay, so remember, the rule for the median is we're just going to arrange this data in order, and then we're going to take the number that's in the middle. Now notice the 16.7 is already in the middle, but not when it's arranged in order. So if we wanted to organize this list, if I go back to list, go to ops, and sort in ascending order, we're going to sort list 1 in ascending order. And now I'm going to go back to stat and edit, and now notice 16.7, that's the data element that's in the middle of the data. Okay, so now we have to find the standard deviation. Now the standard deviation has a very ugly formula. Yes, the calculator will do it for us, but we do need to know where that number comes from. So remember, the standard deviation is going to be the square root of the variance. So the variance is s squared, which is equal to the sum of xi minus x bar squared divided by n minus 1. So remember, we're dividing by n minus 1 when we're finding s. If this was sigma squared, then we would just divide by n. Remember the difference between s and sigma. S is going to be the standard deviation of a sample, and sigma is going to be the standard deviation of the population. So let's just show the work for this by hand. So what am I going to do? I'm going to take all of my x's. So I'm going to take 3.9. I'm going to subtract the mean from it, which is 15.44. Then we're going to square that. And then we're going to do it again. We're going to do it for the next element, which was 23.6 minus the mean, which is 15.44. Then we're going to square that, and we're going to keep going. We're going to keep doing that all the way through each of these elements. So ... just show that we've done it for the first one, for the second one, and then for the last one was 28.4 minus the mean, 15.44. Then we're going to square that. So when we take all of those, remember there's 7 of them, right? I've only shown the work for 3 of them, but there's really 7 of them. Take all of those, we're going to add them up. We're going to divide by the number of elements minus 1, which is going to be 6, and then we're going to take the square root of all of that. So now I'm saying we're doing this by hand, but now I've shown the work here. So now all I'm going to do is let the calculator do some of that for me. So we're going to take each data element, 2.7, 2.8, etc. We're going to subtract the mean from it, and then we're going to square the difference. And that's going to go in this list. So up here at the top, let's clear this out. So I've got 15.44, the mean entered in list 2, 1 for each one of those. So now I'm going to take, in parentheses, list 1, which is x, minus the mean, which is now in list 2. Then we're going to square that. And now I've got the squared differences between the data and the mean. So now I have to do this sigma part of the formula, so I have to add all of that up. In order to add that up, that's in the list command. So we go over to math, and we sum. Oh, but we don't want to do it here. This is going to put a piece of data right here we don't want. So I'm going to quit out of here. So now I'm going to go back to the list command, math, sum, and we're going to sum up list 3. So that's the sum of all the squared deviations from the mean. So we're going to average that, so we're going to divide it by 6. So that number right there is the variance. That's s squared. So now we actually want s, right? So here I need to change my formula. Really, we're going to do the square root of that. So therefore, s is equal to that. So we have to square root that number. So we're going to go square root of that, which is 12.27. So therefore, s, the standard deviation, is 12.27. And you go, that was a lot of work. Well, it was, because we could have just gone stat calc 1var stats again, and notice that standard deviation, 12.27, right there.